to kind of revisit some of the things that we finished last year up with doing geometric proofs. I have good news for you. You want to hear it?
Mm-hmm.
Proofs that we do won't be as involved as they were in the past. They won't be as in-depth, okay? But if you guys remember last year when we talked about proofs, especially two-column proofs, you always have to start with what is given and then get down to what's proved, okay? They always say start here and here. I always say it's kind of like the sandwich method. They give you the top piece of bread and the bottom piece of bread. You got to figure out all the ingredients that go in between to make the sandwich there, okay? Remember doing that? Okay? And I have to admit, it was probably your favorite time of the year for math last year when we did proofs, correct?
Yeah, because
I knew
at
it.
the end of the time.
I don't know if I like Christmas.
Proving geometric relationships. Essential question for me, Michael.
How can you prove a mathematical statement?
We're going to do some ways, or look at some ways of proving mathematical statements today, and I honestly think you're going to do really well with this. So let's get rolling on the goals to answer this question. We're going to have to write what's known as a two-column proof. We're going to also write paragraph proofs, a flowchart proof, and coordinate proofs. So really, we're going to look at 4 different ways to prove things. It's not just going to be a two-column proof like we're used to doing. There's going to be different ways to do this. So first vocab up there, proof. Anybody want to read that one for me?
I got you.
Okay.
Wait. Two-column proof?
Just a proof first.
Oh, okay. A proof is a logical argument that uses deductive reasoning to show that a statement is true.
Okay, deductive reasoning. Deductive reasoning is reasoning based on
Deductiveness.
Things you already know.
things you know, facts, right? Okay? Not fake news, but facts.
CNN.
All right?
What? It's stuff I know.
Don't call me snowflake.
Uh-huh.
All right?
Don't call me.
Two-column proof for me. Who wants that?
I got you.
Okay?
A two-column proof has numbered statements and corresponding reasons that show an argument in a logical order.
Okay. So it's our statements and reasons. So I always have my statements over on the left and my reasons over on the right. We'll talk about that in a little bit. Paragraph proof is another proof format, which is paragraph form. It presents the statements and the reasons as of proof as a sentence in a paragraph. So it's just basically writing down what you think. All right, it's just like explain this. So if you were over in Mrs. Jensen's classes, you said, why did Homer do what Homer did in whatever book, the Odyssey? Is he in the Odyssey? Okay. All right.
I forgot that book.
You would write out a paragraph, right? Okay. So if I ask a question, why is this true? We can also prove this in paragraph form, and I'll show you how that works. One that's kind of fun to do is a flowchart proof or a flow proof. Kind of like says, you guys have all seen a flowchart, right?
No.
Like well, have you guys done those mystery books before? Like if you make a choice that says go to page 32, or you go to the other choice that says go to page 64. How many have ever done books like that?
Yeah.
It's kind of what a flowchart is. If you take this route, then you got to go to this page, or if you take that decision, you got to go this way and see if you can get to the end. There used to be a game when I was a kid. It was called Oregon Trails. Anybody ever
Yes.
play? Yes. Make choices all the time, and here's your consequences.
Yeah,
Just
we
like
played
choices,
that in, like,
consequences.
That was super fun.
Okay. Yeah, it was great. Okay.
We were going to call that the new channel.
Okay. Coordinate proofs. Coordinate proofs are going to be a coordinate proof is going to involve placing geometric figures in a coordinate plane. And we're going to use variables to represent the coordinates here. So as an example, you might have maybe you have the first quadrant of a coordinate plane here. And maybe in there we have a triangle. Okay. And maybe this is my triangle in there. Okay, I know at this point right here would be what comma what, kids?
0, 0.
Okay, they might call this point right here, I don't know what it is, it's a certain distance right, they might call it A, comma, how, but it's on the x-axis though, right? Okay, we just don't know what that number is, so they might call this point A, comma, 0. We know what this is 0, comma, 0. And then, is this point on either of the axes, this is the x or y axis?
No.
They might say you go over a distance B and up a height how much? So they might call this point B, comma, C up here. We just don't know what the values are, okay? And we're going to look at how do you prove stuff in coordinate proof today, all right? So you're gonna kinda have some shapes in a coordinate plane, but we just don't know the distance anymore, okay? So we have to use variables instead of actual numbers, okay? Some numbers we can't identify because they might fall at the origin, or they might fall on the X or Y axis, right? Yeah?
Do we still have note checks?
I haven't done it this year, okay? Can I tell you why I haven't done it?
What?
A lot of the reason is because I have all new classes right here, okay? Some of the classes we used to have before that were younger and new, we always wanted to make sure that they were going in the right direction with stuff and getting that down. Secondly, all the new classes that I have, trig, college prep, they're all electives at this point, so I expect them, if they elected to be in there, I expect that they're gonna do what they're supposed to do.
Is that an A0 right there?
Yeah, I mean, I can do no checks for this group, because for everybody that's in here, you're required to be in here. I mean, want no checks to be part of their
I
program.
don't know, that gives us free fun. I mean,
Yeah.
If you're doing your job, it was, right? Yep. Okay. I can go back and do that. Okay. So should we start that in chapter 6? Is that okay?
That was the highlight of my week.
yeah, note checks? Yeah, you
Yeah,
know,
yeah.
marking a test on that.
Oh, yeah. Matt.
Wait, you like coming up to my desk?
Matt said
Yeah.
no.
All right, here we go. Guys, this is just the end of what a coordinate proof is. We kind of talked about what it is and what it means here, so I think we're in pretty good shape there, all right? Okay, let's get rolling here. I'm going to kind of blow this up a little bit here and make some room. So let me zoom in quick. So we are going to write a 2-column proof right here, kids, for the following, okay? There's going to be some... there's going to be some expectation that you remember some things that we talked about last year in Integrated 2, start of Integrated 2 at the end of last year. And I have a question. Any of you guys happen to save your notes from last year at all?
Mine are at home.
Somewhere at home, probably.
Mine are at home.
Okay. I might, gosh,
I did it because you told me to. So I saved my
We
notes.
gotta save these puppies.
You told us.
I might,
What chapter was it? I still have.
well, it was probably chapter 9 or 10. I want to say it was chapter 10 that we went through. I might just pull my old ones from Integrated 1 and print them off again that are already filled out and give them to you, because that might help a little bit too, okay? We'll see. We'll see how this goes, okay? Okay, guys, writing a 2-column proof. Here's how this is going to look. First of all, kids, we have some shapes down here, and all these shapes are simply angles. You guys agree with that? Okay, it says to do what, kids?
Or a 2-column proof.
Okay, write a 2-column proof. So 2-column proofs are just like a little T-chart. So here's my little T-chart.
Statements.
And on the left, we're going to put what?
Statements. Or chess.
Yeah, we're going to put our statements on the left. So statements here.
I do not miss these.
That's good. I'm glad you don't miss them, because they're back.
Wait, perfect.
They're not that bad. What?
Statements and reasons, all right? Audrey, you know that yawning is contagious, right?
Yeah.
Okay. I've always told you, always start out with what, kids? Start out with the givens. Okay, so number 1. What's given to you?
1 is complementary to 3.
Angle 1 is, I'm going to abbreviate a little bit, complementary to angle 3. What else is given?
2 is complementary to 3.
And angle 2 is complementary to 3. Okay, that's all it's given, right? So over here I'm going to put a 1 and I'm going to write given. And here's what I want you to do. I didn't have you do this last year, but what I'd like you to do is once you have that first one written, put a line there for me. Because you know what ends up happening?
You all make fun.
Things kind of start running together and they get kind of hard to read. So once you have that, draw a nice line in there, and we're going to have 1 in there, okay? So kids, our job right here, our job is to prove that what are we trying to prove here?
Angle 1.
Angle.
Angle.
Angle 1 is screwed to angle 2. Okay, that's where we've got to get to. So here's what we're going to do, okay? What's it mean if angles are complementary, kids?
They go 90 degrees.
Okay, so what this would mean is this. Let's talk about one being complementary with 3. Complementary, remind me one more time, is
90 degrees.
going to add up to 90 degrees. So here's, by definition of complementary angles, that means, I'm going to put right here, this means the measure of angle 1 plus the measure of angle 3 would equal how many degrees, kids? 90, and that's by, how do we know that?
Complementary.
That's just the definition of what? Definition of, I always write definition, and I'll abbreviate. Definition of what kind of angles? I'm going to abbreviate. This is a definition of complementary angles up here. Okay? Now, are 1 and 3 my only pair of angles that are complementary?
No.
So, how about a statement 3?
The measure of angle 2 plus the measure of angle 3.
Okay, so say it again, Audrey, for me so I can hear you.
The measure of angle 2 plus the measure of angle 3 equals 90.
Okay, so Audrey's saying, hey, I know the measure of angle 2 plus the measure of angle 3 would have to equal what? Okay, so hang on a second. Step number 3. So the measure of angle 2 plus the measure of angle 3 would equal 90. What's the definition, or what's the reason for that again? Okay, so if I put these little, what kind of marks are those called?
Quotation.
Quotation marks up there, it means ditto, doesn't it? Okay. Or sometimes when people are posting on social media, they'll put a pointing up at the previous statement, like that. Okay. So I'm gonna put these down here saying that's the same as definition. Okay. Now, guys, what are we trying to show are equal?
1 and 2. And we know that now.
Okay, we have to be able to get down to show at angle 1 right here. It's going to be the same as angle number 2. I know I did a really good job, didn't I? So, guys, when I get to this step right here, how are we getting close to showing that angle 1 and angle 2 are the same measure?
Well, if they both equal the same thing, like plus, you know,
1 and 3 are complementary, 2 and 3 are complementary, so 1 and 2 are
Okay. Let's look at 2 and 3 together here a little bit. What does 1 plus 3 add up to? How many degrees?
4.
90. And 2 plus 3, angles 2 plus 3 also add up to what?
9.
So guys, if 2 plus 3 is equal to 90 right here, what could I replace the 90 with right here then?
Yeah.
So I can really say is the measure of angle 1 plus the measure of angle 3 is the same as measure of angle 2 plus the measure of angle what?
3.
You guys agree with that?
Yeah.
Okay, so I'm going to write that down here. I'm going to write that down.
You write that down.
Step number 4, we can now say, oh, what happened here? So the measure of angle 1 plus the measure of angle 3 is going to equal measure of angle 1, measure of angle 2 plus what?
Measure of angle 3.
Okay. And the reason for this is going to be, we just substituted. Okay, we substituted. That's the reason. Okay. And for 90 degrees right up here, I said, well, if 90 is up here and 90 is equal to this mess right here, I can put that mess in up for 90. Right? So here comes my line to keep this nice and organized. So that reason is substitution. So help me out here, kids. What are we trying to show? Okay. Hey, take a look at this. Measure of angle 1 plus the measure of angle 3 equals measure of angle 2 plus the measure of angle 3. What angle is common in both the left and right side now? So just like an equation, could I take angle 3 out of there? If I subtract angle 3 on the left and get rid of it on the left, don't I also have to get rid of it on the right? So what could I subtract out of there on both sides that's common? Okay, so in step 5, you're going to say the measure of angle 1 is what? And we did this because, what do we do to both sides? So we're going to say this is subtraction. Property of what? What'd you say? I like that. Subtraction property of, how about we go equality? Because equations are equal, right?
Isn't breakfast for lunch today?
Yes.
Oh, it is?
Yes.
What kind of breakfast?
It's a regular breakfast, but it's not.
Okay. So here's the deal.
Sunscreen.
It's probably late.
I've shown that measure of angle 1 is equal to what?
2.
The measures are the same, so what must be true about them? We were actually trying to show that they're not equal. We're actually trying to show that they are, what's this symbol?
Probably.
Congruent. So what I'm going to say here in step number 6 here is, well, if the measure of angle 1 equals the measure of angle 2, that means that angle 1 is congruent to angle number what? Because your reason would be,
If they're equal, then if they're the same, then I'll do the same thing.
here's your reason. You want your reason?
That's the way it is.
That's just a definition of what? Definition of congruent angles. I kind of like doing it this way. This is kind of nice. I think my writing's better with this. It doesn't break up sometimes. There's all your reasons right there, kids. Right? Now, here's the deal. 2 column proofs. We've kind of talked about it. First of all, do you guys follow me through that proof?
Yep.
You say follow us or follow?
Did it good?
Well, did you follow me through the way I
Yeah.
okay? I used deductive reasoning all the way through that to get down to where I wanted to get to, okay? So example 2 comes back and says, oh, by the way, maybe you don't want to do it in this format. Maybe you want to do it in what's known as a
Paragraph.
So do we just turn those all into sentences?
basically you can turn this into sentences here. So let's start writing. I'm actually going to type up there. Is that okay? You guys okay with that? Make this look nice. So here's kind of what I'm going to write here.
To us?
Send me the link.
Oh
The
gosh.
DM.
I got 11 Ds.
Mike Walker, not Mike. Adam, how many users of Musical app?
So guys, let's start out with this right here. Let's go back to the top here. What did we know right away, kids?
That 1 is complementary, 3 and 2 is.
Okay, so I could say because angle 1 and angle 3 are complementary, so I'm going to do that real quick. I'm going to go down here, and I'm going to start writing right in here, text box. Okay, so the first thing that you know up there is because, gosh dang it,
13.0.
because angle 1 and angle
You just have to count.
3 are, what's the word?
Complementary.
Okay.
They add up to how many degrees?
90.
I just put R.
Okay, you alright with that first sentence?
No, it starts with because.
Yeah, you never put start a sentence.
You can too. Did we go to
Just
basic
math,
English?
No, yeah, that's what they say, but that's what they said in like second grade.
Mrs. Glady got
Miss
triggered.
Jensen
Mrs.
said
Benson, I think, got
It is actually
triggered.
okay.
No, Miss Jensen told us we can't.
Yeah, it's okay.
Probably
Mrs.
legal
Leadham, yeah,
Miss Lee was.
no, let's not even say
It's okay as long as we're not like.
No, you can use
As long as you're not like.
They're just
cutting it
There
out.
we go.
It's just a way.
Since angle 1 and angle 3 are complementary,
Let's go ask Mrs. Jensen.
they will add up to what?
Yeah, we should. Can I go
We
ask
should ask
her?
her.
Let's go
I don't
ask her.
think she's busy.
Yeah,
Does she have a class right
I
now?
don't think so.
Sure.
Should we go ask
Go
her?
get her.
I think there's only specific terms that you can use because.
Can you start a sentence?
No, ask
Come
her.
on.
She says, of course.
To
She
ask
says,
her.
of course.
Oh, change the sentence.
Can you come over here, please?
This is what I'm
This is
doing.
a big deal.
Michael, you better be right.
I'm not saying nothing. Adam, starting.
Coming over.
Yeah, she's coming.
So yeah, when can you start a sentence with because and when can't you?
You have to have.
Oh my goodness.
Can I write on this?
Yeah,
on
go
this?
for it.
Okay,
Because he started
Now,
with
can I
because.
tell you what context we're in right now?
sure.
So what we've done here, so we're giving three angles up here right now.
Okay.
And this is the information that's given to us.
Okay.
Angles 1 and 3 are complementary, 2 and 3 are complementary. We're trying to show that angle 1 and angle 2 are the same. Okay?
Okay.
So we have a 2-column proof format up there with statements and reasons. Okay? But there's also another way to do this called paragraph proofs. And
Yeah.
paragraph proofs is all about reasoning, they're saying,
Yeah.
so I'm sitting here
Paragraph
starting,
proofs are
I
awesome.
started with because, I said write a paragraph proof for example out there. It said, so because angle 1 and angle 3 are complementary, they will add up to 90 degrees.
Is that
Yeah.
correct?
That's correct.
But then everybody's
Now,
like,
I
no,
put
you
the
can't
word
start it.
because up there and they flipped out on
I
it.
know my freshmen didn't flip out on you. I know they did not flip out on you. So,
It's really just Michael and
It was
So
just
I
Okay.
got mad and I threw sense in there.
Michael and Adam, you guys, the reason that you're told, like, when you're little kids that you can't start a sentence with because is because they, yeah, you did. I can do this, is because you stop there. When you're in first grade, you're just like, because angle 1 and angle 3 are complementary. And you can't do that. You have to have this independent clause right here. An independent clause won't have a word like that before it.
So the because part is like the dependent variable for this independent variable that we talk about all the time in math.
Wow.
Or let's think of independent and dependent as a statement and a
Clause.
Oh, it's like we're almost saying statements.
I don't know.
I don't know about you, but I think we just went cross-curricular.
Yes, thank you.
Okay,
Mrs. Jensen.
so
You guys should always teach kids.
I can do because, right?
I don't
In
know.
a certain.
Actually, since is.
So now I'm gonna change it back now.
No. Okay, so they add up to 90 degrees. So what else can I say after that? Also along those lines, what else was complementary? I can say, how about this? Likewise, angles. What other angles are complementary?
2 and 3.
Likewise.
Are we good there? So now, kids, you're basically just taking this 2-column proof and you're putting it into words, all right? So we've kind of said they're complementary. We've kind of said angle 1 and angle 3 add up to 90, angle 2 and angle 3 add up to 90. So our next sentence would really be line number 4. So how would you turn number 4 into a sentence up there? So you could say, since both sums are equal to 90 degrees, the two sums must be what?
Equal.
Okay, so I'm going to say since we can say what?
That they are equal.
Angle 1 plus angle 3 must equal angle 2 plus what, kids? Angle 2 plus what?
Angle 3.
All right, now I can say subtracting angle 3 from both sides subtracting angle 3 from both sides gives us angle 1 equal to what?
Angle 2.
Therefore, what can I say?
They are
Angle 1 is, what's the word? 2.
Wait, do we have 4 English teachers?
Are you gonna make us write this on any?
I'd like you to.
That's rough.
Guys, I gotta tell you this right now. As I look at this, right here, we weren't big fans of two column proofs. Is that true or false?
True.
But I gotta be honest with you.
Easier than this.
It's just, I just like to explain it. I don't like to write it all out.
Yep. Putting stuff in words is pretty important. And maybe what I should do for an assignment sometime is have you guys video yourself and then turn it in that way. Speaking.
Don't do the frown thing. That was
I'd
not-
rather do that than write it all out.
But you know what? I think that would be a good idea because, you know, and
Yeah.
Or while you check our notes, we can just explain things.
Yeah.
okay. So that's, you know, look. I like this right here because I can follow my reasoning all the way through in example 1, okay? I get into this right here and I lose track of my reasoning sometimes.
Me too.
Makes sense? But I'm going to tell you this right now. This paragraph proof really kind of came from being able to reason logically and sequentially through this, okay? Now another type of proof, and I'm going to wait. Does everybody have that written down there, first of all? Oops, I'm going to get rid of the red up here. Oops.
I have a question.
Yeah.
Is sense supposed to be capitalized like this?
Oh my god.
No, Michael, that was emphasized.
I don't know if that's proper.
Michael, thank you for noting it. I appreciate your input. I will I'll check into it and I'll get back to you, okay? Sound good? I'll go to my sources.
Is Mr. Bierman, is he like an English teacher?
Yep.
Yeah.
So we have Mr. Bierman, Mrs. Leadham, Mrs. Jensen, and
This is Michael.
4 English teachers. That's crazy.
Yeah.
We only have 2 math teachers. Oh, we have 3.
3.
Wow, that's crazy. We have so many teachers.
Okay. Let's look at the next one right here. Now this next one's going to be kind of goofy. Again, we know that 1 and 2 are, 1 and 3 are complementary. 2 and 3 are complementary. Flowchart proof. This is kind of fun. I think these are kind of fun.
We got 7 minutes.
We'll get there. Get this flowchart proof done. Might take a break here. Okay. Flowchart proofs. Pretty simple. You ready?
Yes.
Okay. here's the deal. Flowchart proof, we're going to do the same exact thing. And it works like this. All right, it works like this. You ready?
Yeah.
First thing that we had here was, I'm going to make a little box here. I think you should do the same for this as well. Text box. Where's my text box? There it is. Okay. First box I'm going to put up there. You ready?
Yes.
Whoops. Okay, text box. Here we go. First thing you're going to put up there, angle 1.
That's a good thing.
Is it okay if I write 1? 1 is complementary to what?
Type on the computer.
1 is complementary to 3. You guys got it?
Yes. That's gonna be awful for you.
Yeah, I don't want to do it this way. I'm going to write.
There's probably someone who can get some voice
Zero
like
has an
that.
O.
How do I delete this?
Daddy's back.
Just go to your keyboard.
Just straight
Yeah.
to the side.
Goodbye. I'll do it this way. Here's how we'll do this.
You can make the letters out of the shapes.
Ooh, this will be fun. Okay, so we know angle 1 is what?
1 is complementary to
Okay. Okay, so once you know 1 is complementary to 3, what's that mean?
They will not.
Okay, so I can write, I'm just going to make a box right here. That means the measure of angle 1. That means the measure of angle 1. I'm going to write it this way. Yeah, measure of angle 1 plus the measure of angle 3 would equal what? Okay, and this is what here again, kids? On the arrow, you would say, well, that's given. We can go from here. This is given. Okay. So right below this box, this would be the definition of what kind of angles are these? Okay, the reason I can say this is definition of so in this right here, really what you're doing is you're putting your reasonings in a box. You're putting your reasoning in a box, and then you're putting your definition right below it. Okay. Now from there, we also know what else. I'm just going to make another box over here. I don't care where it's at. I'll put the box right here. What else was given? 2 is what?
Complementary.
Okay, because that was what? Given. That means that angle 2 plus angle 3 is going to do what? So from there I can go what? Say, well, from here I can say angle 2 plus angle 3 has to equal what? Right? Okay? Because that again is what?
definition of
Definition of complementary angles. Okay? Now watch this right here. I'm going to come back in here and I'm going to put a box right down here. This is equal to 90 and this is equal to 90. Off of these two boxes right here, I'm going to put another box right here maybe. I don't know. Okay? I could say angle 1 plus angle 2 must equal what? I'm sorry, angle 1 plus angle 3 must equal what?
90.
Well, we already had it up here.
Equals the other side. The 2 plus 2.
So I kind of took this part of this and I went from here to here, but I also went from this box to here. We basically took this box and we combined them by what? Well, substitution, right? I don't either. Okay?
The only part I don't like about stuff like this is it's like you're like explaining it to someone who wouldn't know how to do it. Like they can't just assume anything.
Right.
It's like I get halfway through it and it's like obviously this is what it is, but you still have to learn a lot.
Right. So here's the deal. Where am I going after this now, kids? We're trying to show that 1 and 2 are the same, so what are we going to do to both sides?
Subtract 3.
Okay, so I can say angle 1 is equal to what? So from here I can go and say, okay, from that we can say angle 1 is equal to angle 2 by, I'm just going to put SPE in here as a reason. Subtraction, property of what?
Equality.
We're really restating the proof, aren't we, again? Okay, so if angle 1 is equal to angle 2, where can I go from there? Well, kids, what's that mean about your angles if they're equal? They are finally what? Okay, so angle 1 must be congruent to angle 2. That's what we set out to prove.
Perfect timing.
Okay, I don't care for that type of proof. I'm telling you, kids, paragraph proof,
It's the way to go.
flowchart proof,
And
or the 2-column proof that we've done in the past.
yeah.
I still say
Nowadays.
2-column proof is the way to go. Now, again, kids, when I hand out an assignment, when I get ready to hand it out, don't panic too much because I am going to help you through these. Okay, I think proofs are tough. I think kids struggle with them normally, and I'll do my best to guide you through that stuff. But I'm going to stop there right now. We'll pick up the last example in class tomorrow. So let me